In our last example for section 1.7, we're going to be looking a little bit, or we're going to be looking at a couple of properties of a curve, and you'll see a little bit more of this on your next homework assignment. We're going to be looking at a curve called the Witch of Agnesi, and it is a curve studied by the Italian mathematician Maria Agnesi in the oldest known surviving mathematical publication by a woman. It is a curve of the form y equals 8a cubed over x squared plus 4a squared, where a is a constant that is greater than 0. So I will emphasize that here because we're going to be treating a as a constant throughout this problem. So part A is just asking us to compute this integral of 8a cubed over x squared plus 4a squared dx. And so we want to think about some different strategies that we have for doing this integral. There's only one x that shows up in this integrand here, and it's this x squared here in the denominator. So maybe that is an indication for us that u substitution isn't going to be a super helpful strategy for us, at least as of now, because whenever I use u substitution, I want to pick something for u, and then the derivative of u needs to show up somewhere else in the integrand. But if I pick u being something that involves this x here, the derivative of u isn't going to show up anywhere else in this integrand. So that's not going to be very helpful for us. Instead, what I'll notice is that this looks like the integral formula that involves arctangent. This looks maybe kind of like 1 over x squared plus 1. And in fact, it is going to be very similar to that. We just need to deal with these constants appropriately. So we can factor the 8a cubed in the numerator out of the integral. And so that's going to get me 8a cubed out times the integral of 1 over something dx. With the denominator there, I want to get this constant term here to be 1. So I'm going to factor a 4a squared out of the denominator there. So 4a squared, and I'm left with x squared out of 4a squared plus 1. Let's maybe write that a little bit neater. All right, so we've done a little bit of work to simplify the integrand, or at least it now looks a little bit closer to the integral related to arctangent. So let's see. So let's simplify the constant term there out front of the integral. So 8 over 4 is 2. A cubed over a squared is a. And now we want to think about this term here, this x squared out of 4a squared, and we want to think about, is that something squared? The answer is yes. It is x over 2a quantity squared. And now that I've written this as 1 over something squared plus 1, I want to let u be that something. So here I'll let u equal x over 2a. This tells me that du dx is 1 over 2a. And so dx is going to be equal to 2a du. Great, so we can do this substitution now. So I have 2a out front. I have the integral of 1 over u squared plus 1. dx I'm going to replace by 2a du. Cool. So I now have, I can factor this 2a out of the integral and combine it with this 2a to give me a 4a squared. And this integral is exactly arctangent, plus some constant c. Going back and replacing u by its expression in terms of x, this is going to work out to be 4a squared arctan of x over 2a plus c. Cool, so we have an antiderivative here. we want to maybe use this in part B, which is asking us to compute the integral from 0 to n of the same function for an arbitrary upper limit of integration, some positive n value here. So we know that in order to do this integral, 8a cubed over x squared plus 4a squared dx, all we have to do is find an antiderivative, evaluate at the upper endpoint, evaluate at the lower endpoint, and subtract. So we just found an antiderivative. It is this 4a squared arctan of x over 2a. And so we want to evaluate at the upper endpoint. So we have something like 4a squared arctan of n over 2a. And we want to subtract the same thing evaluated at the lower endpoint. So 4a squared arctan of 0. So maybe we want to take a moment to think about what arctangent of 0 is. Again, arctangent is going to spit out some angle between minus pi over 2 and positive pi over 2. It is, arctangent also takes as input the slope corresponding to a given angle. So here, if I'm thinking about this input as representing slope of an angle, slope of some angle on the unit circle, then, slope of 0 corresponds to a horizontal line. The only way I can draw a horizontal line here on my unit circle is if I draw this one. And we want to think about what's the corresponding angle there. The corresponding angle is 0. So arctangent of 0 is 0. And so I can conclude that we have a nice formula here for a squared arctan of n over 2a. On the homework, you'll be using this formula and some facts that you know about arctangent in order to think about maybe what this integral means geometrically and how it creates kind of an interesting sort of geometric object that we can think about.